Hello and welcome to the Actuarial Trusted channel, the channel where we break down actuarial exam questions step by step so you can answer them accurately and on time. In this series of videos, we are still tackling utility theory, and I had given a list of all the exam questions from this topic earlier. You can check that in the introductory video. In today's video, we'll be tackling October 2020 question number 1. This question is 14 marks. These are significant marks in the exam. So we'll just dive right into it and start. Question 1. We'll start with the very first one. Let's read through the question. State how the following economic characteristic of investor can be expressed mathematically in a utility function U of W for wealth W, defining any further notations you use. So we'll just write the answer here. The first one is non-satiation. And non-satiation is the first derivative of the utility of wealth. It is always greater than 0. The second one is risk aversion. This is the second derivative of utility of wealth, and this is less than 0. The third question is increasing ARA. So this is the first derivative of ARA, and if it's increasing, it's greater than 0, where ARA is given by minus second derivative of the utility of wealth divided by first derivative of the utility of wealth. And then the third one is decreasing ARA. So again, this is the first derivative of RRA, and it is decreasing, so it is less than 0, where the relative risk aversion is given by this formula here, minus wealth, second derivative of the utility of wealth, first derivative of the utility of wealth. And with that, we have our 3 marks, easy. The second part is asking a new insurer uses a quadratic utility function. We are given that where D is less than 0, derive the ARA of the insurer's utility function. So we already have the formula of the ARA here. So we are given the utility of wealth for this investor is W plus D wealth squared. So the first derivative will be 1 plus 2D W, and then the second derivative will be 2D, and this gives an ARA of the first derivative here is 1 plus 2dw, and here we have 2d. So with that, we also have our 2 marks. And then the third part is asking demonstrate whether the insurer's ARA is decreasing, constant, or increasing relative to wealth. So I'll just write this in another form that is easy to follow the derivation. Oh no, here I made a mistake. This is 2d divided by 1 plus 2dw. So I'll just write minus 2d 1 plus 2dw raised to minus 1. So the derivative to find if it is increasing, constant, or decreasing will be minus 2d one plus 2dw. This will be raised to minus 2 the derivative is 2d, and then since it was raised to minus 1, we'll also have minus 1, making this 4d squared, 4d squared divided by 1 plus 2dw squared. And of course this is positive, greater than 0, thus increasing. Now to the main part of this question, which has the most marks. But so far we have 6 marks, which is good. The insurer is about to write its first 2 contracts. That 2 contracts, keep note of that. The contracts will be identical and independent, each with a 10% probability of a claim. Each claim costs 100, and there can be at most 1 claim per policy. Very important. The insurer's initial wealth is 250. The insurer uses the utility function with D. We are given that. So calculate the premium P that the insurer should charge per policy, so that the insurer's expected utility of wealth after writing the policies is equal to the insurer's current utility of wealth. So you remember in the introductory video, I had given the formula for calculating the premium that the insurer should charge. Be very careful. There's a difference between the insurer and the insured. In this case, we are dealing with the insurer. So the formula that we'll use, which again is also given in the question, is utility of initial wealth plus the premium minus claim will be equal to utility of initial wealth. That is a formula that we'll use. So I'll just demonstrate how to calculate this in Excel really fast. Sorry. So here I'll have initial wealth, which is 250. We've been given the value of D, which is minus 0.001. We've been told that claim is 100. So we have different scenarios. The first scenario is no claim. The second scenario is, since we have 2 contracts, so the first one is no claim on both contracts. The second scenario is 1 claim on one of the contracts. The third scenario is 1 claim on the other contract, and then the fourth scenario is 2 claims, claim on both contracts. So we get the wealth. The wealth. So before that, we have to guess a premium, and our first premium, it's just, this is a guess. You can guess any number, so I'll just guess 10. So our first wealth will be, when there is no claim, it will be initial wealth plus the premiums that we are collecting. We are collecting 2 premiums, 1 for each policy. Then the second one will be initial wealth plus the 2 premiums that we are collecting. And then, since we are only, there's only 1 claim on the 2 policies, we less 1 claim, which is 100. Similar to this, 250 plus you collect 2 premiums, and then you less 1 claim. In the fourth scenario, we have 2 claims, so it's 250. You collect both premiums, 2 multiplied by premium less 2 claims, so that's 2 multiplied by 100, correct? And then here we'll calculate the probability. The probability that you have no claim, we have been given a 10% probability of claim. So the probability that there is no claim is 1 minus probability of claim. So it is 0.9. But we have 2 contracts which are independent. So 0.9 by 0.9. Then this other one will be 1 claim. So 0.1 for the first policy claiming, and then 0.9 for the second policy not claiming. And then vice versa. 0.9 first policy not claiming, 0.1 first policy claiming. And then in this one, both policies are claiming. 0.1 multiplied by 0.1. From there, we go on to calculate the utility of wealth. The utility of wealth, we will use this formula that we've been given here with this wealth that we have. So our wealth, that plus the D we had been given here, multiplied by the wealth squared. D, I'll just add $sign so that I can easily drag. And with that, I have utility of wealth for all the four scenarios. I go on to calculate the expected utility of wealth, which will be some product of the probabilities and the utility of wealth. So that with that first part, I have calculated the expected utility of wealth of the four scenarios. And now what I will calculate next is the utility of the initial wealth. We are just following the formula that we had written earlier. So utility of initial wealth using this same formula here will be wealth plus D multiplied by the wealth squared. And we want to equate these two values. We want these two values to be the same by adjusting this premium here. So I'll just show you how to do it really fast using solver. No, we're using goal-seek. Sorry, I mentioned solver. In exam conditions, you cannot use solver. So even if you know how to use it when you are practicing, you cannot use solver in the exam. This feature is not available in the exam. The available one is goal-seek. So by changing the cell for the premium, I will set cell this to be equal to 187.5. 187.5. And with that, I know that the premium I should charge is 11.81. So now what I need to do next is just copy that for the examiner here. So I'll start with utility of initial wealth, which is 250 plus D we had been given minus 0.001 multiplied by 250 squared. It is this value here, 187.5. From there, we are now calculating this other part. So expected utility of wealth here will be, we are going to use the information that we already calculate, information that we already have in our Excel. So the first one will be 0.9 squared, and then utility of wealth when there is no claim. You add 0.9 multiplied by 0.1 utility of wealth when there is one claim. But remember, for this occurs twice, so we'll add 2 there, and then the fourth scenario will be 0.1 squared utility of wealth where we have 2 claims. From there, we'll just show the examiner what we mean by wealth when there is no claim. Wealth when we have one claim, and wealth when we have 2 claims. When there is no claim, our wealth was 250 plus 2p, because at this point we do not know what premium to charge. Here it will be 250 plus 2p minus 1 claim, which is 150 plus 2p. And then when we have 2 claims, it will be 250 plus 2p minus 200, which will be 50 plus 2p. So now we replace that in the initial formula, which is the expected utility of wealth will be 0.81 utility of 0.81 utility of 250 plus 2p plus 0.09 utility of 150 plus 2p. This is 150 plus 2p plus 0.01 multiplied by utility of 50 plus 2p. Remember this one was occurring twice. I'd forgotten to write that, so I'll just twice make it twice. And then we already know our answer. Our answer is 11.81. So we'll just write for the examiner when p is 10, the expected utility of wealth is, then we'll just come here and replace 10. We get 185.7. We have the same thing when p is another number 12, then expected utility of wealth is, come here, that's 12. I would write 187.684, and then from interpolation, when p is, you remember our answer, let me just do it again to show you. Goal seek by changing this value here. We set cell that to 187.5. When p is 11.81, then expected utility of wealth becomes 187.5. And with that we have our 5 marks. So to the last part of the question, comment on whether the policy might be attractive to the customer at this premium. So how do we know if the policy is attractive to the customer? First, we have to calculate the expected claims or the expected cost. So the expected cost is, we had been told, or our expected claims, let's just write claims. The expected claim is, we had been told 10% of claim, so I'll have 0.1, and the cost of claim is 100. Multiplied by 100, I'll get 10. Let me just write here, P is 11.81. Good. So now we are paying a premium of 11.81, but our expected loss is 10. So this is not attractive. This is not attractive to the customer. The premium charged is higher than the expected loss. Further analysis of the utility function would give better insights. And with that, we have earned our 3 marks. And with that, we have completed that first part. We have completed that first question and obtained all the 14 marks. This is the Actuarial Raster channel. Subscribe and join me as we tackle more actuarial exam questions together. See you in the next video.